I'm pleased to welcome now Dumitra, our security operation analyst and InfoSec enthusiast, who will talk today about cloud security threat landscape and how to get from engineer to inside threat in only 5 clicks. Enjoy.
Okay. Hello everyone. So I chose this topic mainly because for the past 2 years I've been chasing around engineers that just didn't pay really good attention to cloud security or cloud setup. Um, how many of you work on cloud security? I see you. Okay. And how many of you work on cloud? Okay. So, first of all, who am I? I'm no longer a SOC analyst. I'm a threat hunter at CrowdStrike. I hunt bad guys now. I'm one of the B-Sides Bucharest community co-founders. I'm a big supporter of the community. I attend all the meetups and almost all the conferences around the country and in Europe mainly. This year was my first year at DEFCON also. That was amazing. I have about 4.5 years in the InfoSec trenches, and on a daily basis I'm a slave for Ken. So, the cloud. Why this picture? My former manager at Adobe told me that, Dumitra, you cannot go to an InfoSec conference without a proper cat to slide ratio. So yeah, this is for him. So, a large number of organizations around the world are going directly to cloud as a choice for their infrastructure. This choice is mainly made because of the reliability, scalability, and it's really easy to deploy. You don't have your team, but now you only have the cloud provider and the cloud team to manage your infrastructure. Public cloud also changes the security paradigm. It brings new challenges. It changes a bit the way we implement our infrastructure, and we do not adapt as fast as we should. And also there's a split responsibilities when it comes to securing your assets, because in infrastructure as a service, you are the only one responsible for securing it. In platform as a service, you share the responsibility with the cloud provider, and in the software as a service, the entire responsibility, or most of the responsibility falls on them. So, cloud is such a diverse term. We have a lot of providers in 2019. Each of them have their own naming conventions, and the discussion can get a bit chaotic. While each provider has its differences and specific things, the general process to set up a cloud infrastructure and maintain your application on cloud is the same. You just need to be aware of the nuances. For example, there's not really a big difference between S3 and Block from Azure. Not a big difference when it comes to Kubernetes either, and yeah, I'll talk about it a bit later. And basically, all the offerings are kind of the same with small variations in implementation. I don't want to say that everyone copied AWS, but they kind of did. And added a bit of flavor with, to their services. Okay, so how does cloud work? We all probably interact with the management UI, that's the cloud portal you log on to, where you control all your services. that management UI has in the back of it and sends the information to a control plane that actually manages your cloud. And that control plane takes the information that you give it to the management UI or directly to the API and deploys the services for the customers. Those services are presented in the data plane. Okay, so how do you interact with it? As I said, if you're a cloud admin or you have your own personal account set up for either Azure, AWS, or Google Cloud, you probably interact with the management UI. You go into the web interface. Let's say you spawn some services, or you create your own, I don't know, sandbox to play with it. You interact directly with the management UI that, as I said before, sends the request to control plane and implements everything. If you're an organization that uses automation, like Terraform or Salt to make deployments in cloud, that usually interacts directly with the control plane through the API. And of course, in the data plane, you might have, or usually have, a load balancer to balance the traffic between your servers. You have the VMs and the storage, which you reach through the control plane. And if by any chance you also have a CI/CD pipeline in your infrastructure, your developers might interact with the cloud through an automation service like Jenkins. So when they hit commit, they are able to deploy directly on the cloud. So what about security? This is a survey that was published for 2019 by ICS Squared. In the survey, the results were the following. 93% of the organization are either moderately or very concerned about their cloud security. Out of the organizations that have concerns about cloud security, 64% of them feared data loss or leakage, 62% feared data exposure, and out of the organizations that had incidents, and hence my talk, 40% has had incidents because of the misconfigurations of the cloud platform, and 42% due to insecure interfaces or APIs, and of course, everyone's favorite, unauthorized access because of what we talked earlier, admin. Sorry. Okay. And this is an even better report from Symantec. Yeah, I hope you like the meme. So, in this report that Symantec published for 2018, they discovered that 73% of firms had cloud incidents due to immature security. 63% of the security incidents have occurred in the cloud in the past 12 months. And what I found really funny is that 69% of the survey respondents think that their data is already on the dark web for sale. So, how did we get here? Clearly, the clouds were built to be resilient, to offer availability, and not necessarily to secure what they run. That's where we come in. Another priority for the cloud, and I do understand this, is the ease of use. So if you click next, you have a deployment in like 5 clicks, but that does not make it secure. And yeah, large adoption of the cloud brings a bigger cloud surface attack. The shared responsibility creates a bit of chaos. And my favorite example here is, I'm not sure if you're familiar with the Azure DevOps offering. It's an offering where they give you everything from GitLab until deployment, and you move across the infrastructure as a service, platform as a service, software as a service through the entire pipeline. And yeah, when I asked an engineer that held a presentation about it, okay, so where does our liability interact? Where does our liability end when it comes to security? Because you have so different offerings in this DevOps pipeline. He told me, yeah, we're GDPR compliant. So yeah, there's a bit of chaos there. Also, organizations did not adapt as fast as they could in cloud. They mainly just took snapshots of what they had in data centers and moved them on cloud. Not all of them rewrote the applications to be really cloud friendly. And also, from a security perspective, it was hard to learn how to move things around the cloud. From my experience, the hardest thing I had to do on cloud was to do forensics on a host that had 300 gigs and was on Azure. Good luck downloading that. And another pain point was trying to respond to an incident, needing the traffic, and then considering the cost of traffic capture in AWS. That's a lot of money. Also, security vendors are not really adapted to the cloud. Again, some of them, I mean, when you move to the cloud, you usually do it because you have a lot of infrastructure and you have a lot of traffic. I don't really see much point in selling IDS on cloud, for example. So some of the security vendors need to adapt. Not all of them offer security monitoring for cloud configuration, vulnerabilities that not all of them, or only a few of them scan for risk that comes from misconfiguration. Okay, so what can go wrong? I think most of us, if not all of us, read at least one article about data leakage that was caused by S3 buckets being exposed. Another favorite of mine was the incident at Tesla last year, probably because it's linked to Kubernetes as well. So what they did, they deployed Kubernetes in the cloud, in AWS. They left their management interface open, facing the internet facing. You shouldn't do that. And they also left, of course, the default passwords. So the attackers were able to get in pretty fast. And if that wasn't enough, in that management console, they also had the keys to their AWS subscription. So the attackers could just go in and deploy miners and make profits. Okay, so the threat landscape. Yeah. I should represent a bit of my current employer. These are the cross-direct naming conventions. So, nation states, they usually target intellectual property, so they will walk all over your clouds to get what they need. They also might harvest credentials for later attacks, and of course they might also use your infrastructure to hide their true identity in later attacks, if you allow them. In e-crime, which we mainly name all the adversaries there as spiders. What I've seen in e-crime targeting the cloud, they're mainly after fast profit. On Linux servers, I've mainly saw them deploying miners for cryptocurrency. And if you have any Windows servers with RDP open to the internet, you probably had at least one ransomware on it. And yeah, our main focus for today will be the insider threat. So, an insider threat is a risk that comes from within your organization. And they are split in three main categories. Malicious insiders that really do intend to harm your organization, and they will use all their access to do that. The ones that I'm focusing on today, there are negligent insiders, which are people that expose your organization at risks. probably not, or maybe due to negligence, or because they do not know exactly what they're doing. And infiltrators, you might have some of those as well. If some good APTs are targeting your organization, they might have someone infiltrate your company and gather as much information, as much data as possible. So yeah, let's play a little game. I'd like to walk you through a scenario that will show you exactly how easy or what gaps we leave for, how easy it is to leave gaps for the attackers if we do not pay enough attention when we configure our cloud infrastructure. So yeah, this is a typical cloud infrastructure. Let's say that you work for a company, Cupcake.inc, and you're running a typical native cloud application. So you might need a server to run the app on, maybe another VM on the backend. You have the load balancer in front, of course, to balance your traffic, and some storage, probably or hopefully not Mongo. You have your cloud admin, the management portal, the cloud control plane. You interact with the cloud as we mentioned before, either through the management UI or the control plane. Other engineers might interact with it through automation servers. They might be Terraform, Salt, Jenkins, or whatever you choose. And yeah, the pipeline that talks directly to the control plane. And yeah, of course, the users that go through the load balancer that should reach the application. Okay, so I found this to be the easiest cookie to steal in cloud environments, the subdomain takeover. Let's say our organization, Cupcake.inc, is a pretty big one, so the cloud department or the cloud management administration department and the department that handles the DNS configurations are not the same, and they don't really talk as fast as they should to each other. As you might know, resources in the cloud can have very limited time to live. Servers are spawned and killed on minutes, seconds, daily basis, depending on the spikes of your traffic. And the people that decide how much a server or an application has to live do not always talk to the people that handle the DNS. Since this is such a dynamic environment, the team that manages the DNS might fall a bit behind in deleting some data. So the subdomain takeover occurs when the subdomain, let's say storage.cupcake.net, points to a shared hosting account like an S3 bucket or blob that is abandoned by its owner, and this leaves the endpoint available to claim for yourself. You can actually go and register it on your name. To find this vulnerability, it's as easy as querying for that or trying to get that page. If you get a 404 not found and no such bucket, there's a bingo that's vulnerable. And once you've identified it, it's just as easy as going and registering the subdomain on your name. This is actually a big thing in bug bounty, so if you want to make some money, I'm going to give you some tips. These are two useful tools. So Radu mentioned Rapid7. They have another project that's called Sonar. Sonar scans the entire, or as they can, from the entire internet, and you get all the scenes stored in a JSON that you can download daily and use it. And what you have there in the second link is a link to Jake Jarvis' GitHub to a tool called Subtick. What Subtick does is downloading the most recent data from Rabbit 7. It gets the list of the organizations that are registered to a bug bounty platform. It scraps only those names, and then it tries to get the links. If by any chance the script gets back the message that the bucket is not found, it will add the name of that domain to a list that you can later take on and register or submit it for a bounty. So yeah, good luck in making money. Okay, this is a close contender. The storage with improper conflicts. Continuing the scenario, we started with cupcake.inc. Let's see how this scenario plays in. Let's say that your team member is new to cloud infrastructure and does not have a lot of security knowledge, and you're tasked to configure some storage accounts in, let's say, for example, AWS. Our engineer goes to the portal, they select the proper storage account, they link it to the app. At the security settings, they offer access to all authenticated users. What do you think that means? Do you think that means that you're offering access to people to your organization? Well, no. That means that you're offering access to everyone that ever authenticated to AWS. For a second example, let's take the same engineer might go and configure something on Azure. The naming convention there is a bit different, but just as poorly chosen. So if your engineer goes there, tries to select the blob storage and tries to choose the proper settings, let's say they choose container level access. Okay, let me translate that. I know it's really easy to understand, not? I didn't understand that first. I couldn't understand why would you name anonymous access to your storage container level access. Why wouldn't you call it just anonymous so we could all know what we're doing there? Okay. And this is another nice tool to have around. I'm not sure if you're familiar with Shodan, but this is something similar but for open S3 buckets. So it scans periodically for open buckets and you have the entire list there. I think for free you have access to like the first 18,000 results, and you can also query through the files in the buckets. So hopefully your buckets are not there. Oh, yeah, and this is a screenshot I took. I'm not sure if it's visible. I just wanted to open the site, and the thing I got on first page was temp.dev.s3.amazon.aws.com. You should, yeah. That should probably not be there. Okay, yeah. So, my favorite ones, expose secrets. Any stock analyst loves being in a security call for 2 hours because someone committed their credentials to Git. So, yeah, remember when we talked about the dev that interacts with the cloud with the CD pipeline? Well, let's say he wasn't paying much attention when committing the code because he just solved a nasty bug that took him about 2 weeks, so he didn't really care, he just wanted to commit fast with the keys in it. So, unfortunately, this is a really common slippery mistake for a lot of people. There are some applications that should help you not commit keys or secrets to Git. I hope you're using it. If not, I'll show you a tool where you can find them online. And so can everyone else. So not properly caring about your credentials, about your keys, can really allow an attacker to fastly take over your entire cloud infrastructure. As Tesla saw, they were improperly handling their subscription keys, and luckily for them, there were only a few subscriptions and not a lot of proprietary information. but that can lead to a chaotic scenario where someone can probably even delete your infrastructure. So this is the tool I was telling you about. SHHGit finds secrets in sensitive files across GitHub, GitLab, and Bitbucket. It's almost in real time. I think it was built based on an API that these platforms offer to query in almost real time what you commit. So everything that's committed publicly in a public Git will get to this website. And I was scared to do this slide because I didn't know exactly what we'll see. But I took a screenshot. Oh, they're not visible. But yeah, you can probably see a username and password in URI in the clouds account there. So if you open the platform, you'll just have to wait and it will automatically populate, and you have all the different key secrets that you can find. Java key store, log file, AWS keys, SSH keys, Google Cloud API keys, everything that you could want. Okay, so default settings. I have a funny story for this one. So, as you mentioned in the beginning, cloud services do not focus on security. They mainly focus to offer reliability, scalability, and ease of use. With this in mind, let's continue our scenario in our cupcake.inc company. Let's say we have a cloud engineer that needs to deploy a VM in Azure. He doesn't really have much experience with Azure. Let's say he only worked with Google Cloud or AWS. So he goes to the main page or on the docs page from Microsoft and sees some instructions there. So that's actually a screenshot from Azure that tells engineers to use an administrator account, only password protected, and leave RDP and HTTP open to the internet. And now you can see on the bottom they do have a warning, but about 2 years ago there was no warning there. And here comes the funny story. I'm allowed to say it because it's already on YouTube, told by my colleague Uzo. So we learned about these default settings because Uzo, my colleague, went to an infrastructure engineer course provided by Microsoft. And during the demos, during the labs, he, as any security geek, he just looked around the host and saw that he's not alone in there. He had someone else on the host with him. So he told the instructor, and once they checked, they saw that the default settings are, it was a Linux host, but it was with SSH open to the internet and only password protected. There are a lot of bots that scan and brute force the cloud, so please don't leave these default. Sorry. Yeah, I recorded a demo for this because Azure is a bit slow and did not want to rely on anything fast. Let me move it to the other screen. Here. Yeah, so this is my personal subscription. I'm choosing to deploy CentOS 7.8. I'm choosing a resource group. You can't really read what's on the screen, right? Okay. I'm just gonna walk through it. I'm setting up a password. I'm leaving, of course, the default settings. And yeah, in the end, what you were supposed to see is that if you choose the default settings, there's no next now. You just save the settings and create. Yeah, it leaves everything open to the internet. The default security group will leave everything open to the internet. Okay, trusting the service. Continuing with our scenario at topic.a, let's say that we're kind of tired about all this hustle with the security thing on the cloud, and infrastructure as a service maybe not our kind of thing. So talking, let's say, with the management and deciding that the biggest risk is our Jenkins server that we heard that has a lot of vulnerabilities, and we also know it has a lot of access across the infrastructure, we decided to move Jenkins on a platform as a service offer. But surprise, if you deploy it with default settings, it gets deployed without security groups. That means in Azure terms, it gets deployed without any firewall, with a default user, but you can choose a username, and it will be deployed internet facing. I'll have a demo to showcase that. Another thing that I found disturbing, you probably heard about all those incidents with MongoDB instances on the cloud. AWS had the idea to replace those with their own offering, that it's AWS Lake, that also comes by default open to the internet for everyone to access their data. So here I'm choosing to deploy the Jenkins cluster. I'm really sorry that you cannot see the default user in there. I'm now just entering and confirming the password, choosing how many machines I want my cluster to have. And yeah, let's fast forward that to the settings. I'm waiting here for it to deploy. It takes a while. So here are some of the resources. It firstly deploys the NICs, but that's fine because that's what I wanted to see. I wanted to see if they have any security settings on them. But at the network security group, you can see they have none. I went through all of the instances. None of them had security group. And there is a default security group that you get assigned on the VPC, that means on your subnet, on that particular subnet on the cloud. And that one, I'm not sure you'll be able to read that either. That one has SSH and HTTP open to the internet. Yep, here. That's wide open to the internet. Okay, so that was our main point. Um, Cloud is not made by design to be secure. It offers you the possibility to secure your infrastructure, but you need to manually go there and make the proper settings. Don't trust the default settings. Base them on platform as a service or infrastructure as a service. I'm really glad that one of the issues on platform as a service was fixed. For example, until about half a year ago, all the Kubernetes as a service offerings from both AWS and Azure became totally open to the internet. They now restricted it to allowing all the access coming in only from the load balancer. As a conclusion, yeah, like I said before, cloud services are not designed to be by default secure. Misconfigurations are the worst enemy you can have from a security point of view on cloud. You should never trust default settings. And even if it's not your liability, you should double check. If you can get the logs from your cloud provider, get them and audit them yourself. You'll probably need to split the bill for that GDPR fine if something happens. So, what can we do? All the basic security things that we do on our infrastructure, on your normal infrastructure as well. Use multi-factor authentication. Don't use the console without multi-factor authentication. That's really easy to steal and provides access directly to control plane. Of course, apply the principle of least privilege on all cloud services, accounts, and controls. Create roles and limit access as much as possible for each role. Use break class account, never root one. So when you have a cloud subscription, you get a root account that's basically what, as its name root, it's in God mode, you can do anything. As it's a best practice never to use that. Create a second account and only use the root account if by any chance you cannot get in your infrastructure. Log as much as you can, gather all the audit trails, configuration logs from your cloud provider, and try to build as many correlation searches for compliance and configurations as possible. And of course, network segmentation. You have those security groups, don't leave them as they are, open by default. Try to limit interaction from the load balancer to your app, from your app to your database, from your dev to test and broad infrastructures. And this is a quote I stole from one of my colleagues at CrowdStrike. When I saw the quote, I said, okay, this is for my presentation. This is the main idea that I wanted to present either way. So your people and process are part of your security posture, just like your firewalls and AVs. So what's the point of doing a pen test if you aren't going to test your full security architecture domain in its current state? So there's no point in doing pen tests and vulnerability scanning or anything if your process and procedures and your people are not responsible enough to pay attention at basic security conflicts like leaving SSH or RDP open to the internet. Okay, so that was it for me. No? I have a Q&A slide, I promise. Any questions? No? Okay, I'll be around. Thank you.